Here's a new style of video that you probably haven't seen before, going back to my roots, and I'm going to be presenting my notes from now on OneNote because it is more environmentally friendly and I could also record it wherever I can. So this makes it a lot more effective from a recording standpoint, and hopefully it'll deliver just as good as product as what the whiteboard videos did. But let's go through continuous probability. Now, the topic of continuous probability is completely new. If you're in year 12 and you're studying this for the first time, then you probably haven't encountered continuous probability before. All of the probability that we've learned up until now, we classify as discrete probability. We put that into the category of discrete probability. Now, the reason why it's discrete probability is because we have a finite amount of events. So we have a finite amount of events, we have a finite amount of outcomes, of possible outcomes for our specific experiment. So just a classic example of this is rolling a dice. There are only 6 possible outcomes that we can have when we roll a dice one time. So you have 1, 2, 3, 4, 5, 6. That's a finite number. And whenever we have this type of event, we can always label probabilities to each of the outcomes. So there's a probability of 1/6 of rolling a 1, there's a probability of 1/6 rolling a 2, so on and so forth for all of our numbers. So that's the special thing about discrete probability. It's that you have a finite number of events, and each of those events have their own respective probabilities, and they all add up to 1, just like any other probability or any other scenario. Now, the layman's terms for talking about discrete probability is a term that we call countable. So if you have countable outcomes or countable events, that it's usually classified as discrete. It's not necessarily a specific definition for discrete probability or discrete probability events, but it's more so just a layman's terms that we use to classify discrete probability events. But the actual definition, or if you want, if you want something that's close to a definition, we talk about discrete probability as an experiment that has a finite amount of outcomes, and we associate probabilities with each of those different outcomes. Now, it doesn't necessarily have to be a low number. If you had an event with 1 million outcomes, so 1 million, 7 figures, that is actually still a discrete event because you have individual events that you can count up to, although quite inefficient, counting up to counting up to 1 million and assigning probabilities to each of those different outcomes. That's still a finite event though, because it's not infinitely many outcomes. Now, continuous probability, so I'm just going to write continuous first, leave you on a cliffhanger. Continuous probability, that has an infinite amount of events. And you might be thinking, how do we get an infinite amount of events? It's because we put the experiment, or we model this experiment as a function. And if it's modeled as a function, then it's on a spectrum and it has infinitely many possibilities for the numbers that it can be. So if you have a function that goes from 0 to 1, and again, it's defined continuously as a function, then you have infinitely many possibilities for what x can be, or whatever the number can be. Now, you might be thinking, how do we actually get infinitely many events? Again, it's on a spectrum. So if we think about things that are on a spectrum or a continuum, an example of something like that is something like height. So let's say, for example, I'm 180 centimeters. I think I'm 180 centimeters, right? Now, if I say I'm 180 centimeters, am I exactly 180 centimeters? Or am I just close to it? Do I just round down or round up to 180 centimeters? I probably don't know exactly what height I am, but I know I'm roughly around 180 centimeters. And when we measure things like this, it actually makes more sense to consider a group of numbers or a group of measurements. And specifically for continuous probability, we actually worry about ranges, or we concern ourselves about ranges of numbers. So what's more realistic whenever we're kind of seeing heights of people is we group them into different categories. For example, you might say if someone's in between 180 and 182 centimeters. It actually makes more sense to group people like that because we have a measured event and it's really hard to pinpoint how many people are exactly 180 and how many people are exactly 182 and exactly 181. And also you have half measurements as well. So for continuous events, the layman's terms that we use for them is a measurable event, because a lot of the times our continuous events are usually measurable. They're things like lengths, they're things like heights, they're things like weights. We measure all of those things, and it's really hard to pinpoint and group them into their individual numbers. And if you compare this to the dice example, it makes sense that we wouldn't consider outcomes of rolling a dice the same as outcomes of measuring people, because when we measure people, we can get infinitely many possibilities depending on how many people we measure. And it's also really hard to classify them into individual groups, especially if we have a lot of people. So continuous events, we consider it as infinitely many outcomes, and that's purely because we're on a spectrum, and we consider them measurable events, or the layman's terms for it is a measurable event rather than a countable event. Now, how we actually represent probabilities is a whole other problem, and that is what we're going to be talking about in this set of videos. For discrete probability, you probably remember that we assign, or we make a table, and then we assign probabilities to specific outcomes. So for the dice, we have 1, 2, 3, 4, 5, and 6, and then we say PR, X is equal to X, or capital X is equal to lowercase x, and you have 1, 6, 1, 6, dot, 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 dot. Now, for continuous probabilities, as I said, we're on a spectrum and we define them as a function. So how we define continuous probability functions is just literally by P of X is equal to, and then it's usually a hybrid function, as we'll go through in the actual definition of continuous functions. But it's defined as a function. And how we find the probabilities, I'm not going to rule that in this video. We'll talk about that one in the next one.